Welcome to the Amazon Web Services Cloud. Lift up your business. Start now. Start now.
The CTO of Amazon.com, Dr. Werner Vogels.
Good afternoon. Thank you all for sticking around so long. Maybe because I'm the only thing between you and beer. Yeah, that you're here. At least, you know, I think you're for me here, but okay, no. Something that we did is sort of a dragon's den. Where we had 5 startups, which we selected out of a large set of applicants, to, in front of a distinguished jury, they got the time to get in 3-minute pitches to talk about their new ideas or their startups. And so with 5 of them, Keynote, Stillness, Datafreude, Semiotic Labs, and DataPath. And so the prize for them is $100,000 in AWS credits. Believe me, as a startup, you can live on that for quite a while. Yeah? So with that, I have the great honor to announce the winner of the startup competition, which is Semiotic Labs. Great.
Thank you,
The great thing is that he's going to do a short version of his speech for you guys now. Take it away.
My name is Simon Jagers. I'm the founder of Semiotic Labs. We predict exactly when and why electromotors and pumps fail. By taking sensory data as inputs, shipping it off to AWS Cloud, and then using machine learning to first turn it into patterns of behavior, and then learning which patterns constitutes healthy and which ones constitutes unhealthy behaviors. Our clients use our software to improve operational reliability, lower maintenance costs, but above all, reduce risks. Thank you very much.
Oh, hey guys. Thank you. Congratulations, man. Very good. Good. So a really great part of my job is that I get to meet all these very interesting customers. Yeah, and whether it's new young businesses that are being built out of scratch, out of nothing with new ideas, or whether it's existing enterprises that are really revolutionizing themselves and want to move as fast as these startups are doing. And so I absolutely have the best job possible. Yeah? But to close off with this, sort of as a more, I won't say entertainment, but maybe, you know, for 10 years of AWS, we learned hundreds of lessons, often the hard way. Yeah, and as I think it was Jeff Bezos that once said that there is no compression algorithm for experience. Yeah, for us, no, you can't speed things up. You have to live through this. And so I picked, and I thought that was cool as a title, 10 lessons from 10 years of AWS. In essence, I've got more than 10 lessons for you. Yeah, but the title looks good like this. So I hope that I picked 10 of them, or in this case 14 to be real, because I think maybe they may inspire you to look at your architectures and the software that you're building. Of course, they don't need to necessarily immediately be of the scale that AWS runs at, but definitely your security, your reliability, your failure handling are probably not going to be that much different from what we have learned over time. A very important concept within all of Amazon, and whether that is in retail or whether that is in AWS or any of the other businesses is that we are really big fans of Lean. And so Lean is, of course, comes out of the Toyota world with lean manufacturing. But we've seen Lean applied to many different operations as well. And if you're a young business, probably you've read Eric Ries's book about the Lean startup. Now, for us, Lean is all about removing waste. Yeah? And in my eyes, waste is anything that does not benefit your customer. And so these are some of the things that we try to achieve with AWS for you. Yeah? We try to remove all waste in the IT business so that you can focus on your customers. So you can see us as the IT garbage man. Yeah? We try to remove all waste from you where you are not, so that you don't have to waste time on things that don't matter for your customers. So let's take a look at some of these lessons. Yeah, the first one is something that we actually already knew when we started building Amazon S3. Yeah, when we were sitting in a room and we were thinking about what kind of order of magnitude we should build this system for. And the one thing that we did was actually when we thought about how many objects there would be stored in there, just for the heck of it, we added 2 orders of magnitude to it. We burned through that numbers in the first 6 months. And so the one thing that we knew, that was not unexpected, by the way. The one thing that we knew up front was that if we were going to be successful, then we would have to revise the architecture over and over again. And so we had to build a system in which it was possible. But we were also realizing that when we were building this system, people would build their businesses on top of this. And as such, something like taking the whole system down for an upgrade was not going to be an option. Even though we would have to change the software dramatically, time over time. And so the focus was really on how can we build an evolvable system. Something that we would never have to take down to do upgrades. I like to believe that we've been rather successful in that. I think one of our colleagues, a distinguished engineer at Amazon, Marvin Timer, once actually described this, that S3 started off as a single-engine Cessna plane. Then it became sort of a 737. And then a fleet of 747s. And now it's a massive fleet of Airbus 380s. Yeah? And every time we moved customers over from one airplane into the other airplane while refueling in mid-air, and the customers never noticing anything. Because we've upgraded and changed the architecture of S3 several times without you ever noticing this. And so that was one of the things that we did really well from the start. Something else that we actually already knew almost from the beginning, but that we learned hard lessons around, was that everything fails all the time. Yeah? And that has nothing to do with buying cheap hardware or anything like that. Actually, we've always taken the opposite approach. We're not buying white, cheap boxes to support you. Not at all. We buy high-end enterprise-grade systems to make sure that you have the highest reliability at the hardware level as possible. We did know that we had to mask many different types of failures. And the one thing that I mean by unexpected is that there are so many failures that you're going to encounter that you did not anticipate up front. Yeah? For example, in my mind, TCP packets can never be corrupted. Why not? Because checksums on them and things like that. It turns out there's all sorts of hardware failures that can actually corrupt TCP packets after that let's say the sequencing engine has processed them. And there's all sorts of hardware failures in memory modules that will just corrupt data structures. To the point that we've come to put CRC checks on the data structures itself to make sure that we understand whether the data in the data structures is valid or not. And so you have to think about not just what are the common failures that you expect. Yeah? If you look at a system like S3, which does, what is it, we officially say it does millions and millions of storage transactions a second, which means that on a daily basis, we do trillions and trillions of storage operations. Anything that even has the slightest probability will become reality in your world. And as such, we had to build systems that were resilient against all sorts of failures, even those failures that you didn't know about yet. And so you have to build things in a way. One approach there is what was called recovery-oriented computing. Basically, you take sort of the Windows approach. If you think there is a failure, you reboot. And so let that sink in for a moment, yeah? No, this is actually can be a approach. Instead, things that you think are failing under certain conditions, you shoot them. Yeah, you start from scratch again. If you have sufficient levels of replication, for example, that's an easy thing to do. And it's just like in real life. You know, we as humans are extremely adaptive and resilient to our environment. There's all sorts of failures and events happening around us that we never predicted, yet we're able to be really effective in that. If you are taking the approach that there's only a limited set of failures, you treat the world as deterministic. Well, you know what? The world is not deterministic. The world is chaotic. Yeah? With all sorts of things happening in all sorts of sequences that you never anticipated before. So if you want to build systems that have to survive at large scale in the real world, they have to be adaptive as well. And they have to be resilient. And as such, you've taken a more of a statistical, chaotic approach with self-learning systems to be able that they survive under all circumstances. So this is something that I think has been a success for us. We knew from the beginning that we did not believe that we could tell you how you should be developing your systems in the cloud. When everything becomes software, when everything has an API, you are going to build your systems differently than you would build them on-premise. And as such, we weren't arrogant enough to actually tell you that we should know how you should build your systems. And then that was what I would call frameworks. You know, some companies have been really successful by putting out complete frameworks and then telling their customers, this is how you shall develop software, because this is how we think it should be. That can be successful. That's definitely an approach. It is not our approach. Our approach is to give you a toolbox full of tools where you can decide and pick exactly the right tool for you to use. And not only that, we also knew that if we were going to be successful as a business, we would have a very rich ecosystem working with us to actually, which you should be able to integrate as well. So it's not just that you have all the AWS services sitting in your toolbox. You also have Stripe for mobile payments. You'll have Omniphone for if you want to build a music application. You'll have Twilio if you want to integrate telephony into your application. So the toolbox is much bigger than just that what AWS delivers for you. And so I like to believe that the way that development has changed over time is largely driven by the fact that we've given you these primitives to work with instead of telling you exactly how you should do things. In all of this, automation has been key. Yeah, and I still motivate all our customers to really look at how they can automate their systems. The same goes for us. Yeah? Each of the components, each of the services that you see have, of course, APIs towards you, which you can use. They also have management APIs at the back-end side of this. And I've always taken sort of the litmus test in that if you have to SSH into a server or into an instance, you still have more to automate. Yeah? manual, if there is a biggest threat to all of these systems that we're building, it is humans. Yeah? Human operators are the ones that make most mistakes. Yeah, because remember, we've built these systems that is resilient to all sorts of failures. It turns out that predicting human failures in all of this story is really hard. And so the more you can automate, the better you're off in terms of reliability and in terms of security. Also, I like to believe that if you really look at how to decompose your system and put APIs against them, then you can have business rules drive how these systems grow and shrink. So what I mean by that is, for example, as a business, you may make a decision that let's say you have a web-based system, the current latency to reach your customers is 1.7 seconds at the 99.9 percentile. And you may have this inkling that maybe if you improve the latency to reach your customers, you may see improved conversion on whatever service you're offering. And so how much more are you willing to pay in terms of resources to achieve a particular better latency is a business decision. Yeah, there is a moment in which improving latency further, which costs more, may not have a positive impact on the business. And so being able to actually run your environment driven by business rules is really how you want to build your systems. Well, while talking about APIs, API development has turned out to be very, very complex, and we have spent enormous amount of time on them. And why? Because APIs are forever. Once your customers start building against your APIs, there is no way back. Yeah, unless you want to invest into hunting down each of those customers and helping them build their systems against new APIs. That's not a good plan. Even to the point that we've seen that sometimes customers are screen scraping your console or your web environment and build automation against that. If you know that your customers are doing that, basically those web pages are becoming an API. And you can never change anything anymore on those web pages. Yeah? It's one of the things, for example, where we recently launched the ability to automatically create accounts. Yeah? Because our customers were looking for all sorts of ways to not have this human in the loop when an account had to be created. And instead of them allowing them to actually screen scrape and interact with the web pages, we provided them with a real API so they could automate account creation. This was one that we learned the hard way. So if you build a system, and you build an API, and you put a pricing model against it, you really have to make sure that that pricing model includes all the costs that you are incurring. And that might be hard, but you have to really do research on this, how your system uses resources. And also, what kind of potential workloads you can see that consume those resources. A great example in that was Amazon S3. When we launched S3, there were only 2 parameters over which we charged our customers. Number of bytes stored, yeah, and number of bytes transferred. Now that works really well if you have large objects. However, if you have very small objects, yeah, you are consuming a lot of other resources, namely mostly request rates and things like that. There is an overhead per request. So almost on day 1, we had a customer in S3 that stored millions and millions of thumbnails in S3 for products that they were selling on eBay. And so they consumed an enormous amount of request resources, but the amount of storage and the amount of bandwidth on the wire were minimal. Yet the resources on the system were continuously busy with serving these thumbnails. So we actually had to change the pricing model of S3 to include request rates as well, because that was clearly a different resource that was scarce and that our customers were consuming. This has been a good point for us. When we started doing all of this, we didn't just take existing technology from inside Amazon and then adapted that for the outside world. What we actually did was build things from the ground up. And one of the things that I think is crucial here, that your security team is not a team that does a review afterwards. Your security team is actually involved in building the service. Yeah? Security needs to be built in from the ground up, or you will never be able to have full trust in your system that you have total control over security. Engage your security team on day one to have them help you with creating an architecture that actually can be secured. And it doesn't have something like a firewall around it, because that's how we used to build systems. And remember, if firewalls are the right security concept, we would still have moats around our cities. We don't. You know, we protect individual houses and individual components. And as such, you need to build systems in such a way that they can be protected. We give you all these tools to protect yourselves, but you need to engage your security folks from day one to help you build truly secure systems. In all of this, encryption is a first-class citizen. Yeah, it is so important, but this is the only tool that we have as customers of these kind of systems to really make sure that we are the only ones who have access to our data. And so for us, that meant that we needed to build encryption into each and every one of the services that we have. Now, for example, I mentioned this morning already. Redshift has, you know, each data block in Redshift is encrypted with a random key. All those random keys together are encrypted with a master key. You can bring that master key, and as such, you are the only one who decides who has access to your data, because you hold the keys. Now, it turns out that we all know about this event, this public event that at one moment happened with Snowden and things like that. Before that, we had already been talking to many of our customers that they should encrypt their data. At the minimum, you should encrypt your critical business data and personal identifiable information of your customers. Yeah? And everybody said, yeah, you know, when we have time, then maybe we'll do it. Fortunately, since the Snowden event, everybody realizes how important encryption is and how important it is to actually protect your data from unauthorized access. And the only one who can do that is you, by encrypting your data and managing your keys. We give you all the tools for this. Please make use of those tools. And especially the new encryption, AWS Encryption SDK and toolkit makes it much simpler for you to integrate encryption into everything that you do. So please do this. The network is not something transparent. There are so many different workloads in AWS that it's very hard to predict what the network usage will be for a particular application. And so we couldn't address this in a very opaque manner. Meaning that we just have virtual machines, you have hardware, you standard off-the-shelf networking gear. No, we really had to do a lot of innovation in the network part of our data centers to make sure that you can run any workload. We had to do a lot of hardware innovation, not only by building our own switches and routers, but also at the hosts themselves. So the hosts, if you run virtual machines, actually have a virtualization tax on the network. Yeah, so if you have multiple virtual machines running on your instance, they're basically all fighting for access to the network, which means that most of these network accesses have significant jitter in them. So what we did is we built a new environment with root virtualization where we dropped hardware, network processing into the hardware of the servers. Yeah, and I don't know if you've noticed this, but for the past 2 years, the latency as well as the jitter on the network of AWS has significantly improved. Mostly because we've done this, we've taken the risk to actually find hardware solutions there for you that make it possible for you to have really consistent, good performance on the network. Blast radius is something that you'll hear us talk about more and more. Yeah? If failures happen, remember I said, even the most unexpected things will happen. You have to reduce your blast radius. You have to continuously think about if things fail, what is the impact of the failure of this 1 node, this 2 node, this 10 nodes? And then you have to place replicas of your servers in such a way that even if a blast happens, the radius of that blast is really minimized. And make sure that you actually place replicas in other environments. For you guys, making use of AZs is really important here. Make sure that always you have an ability to fail over to services in other availability zones. This is another interesting lesson that we learned. It was, if you offer a service with a free tier, a new service, you can expect that 100,000 customers will try it out on day 1. That means that on day 1, you need to be ready to take the biggest scale that you can ever think about for your service. Yeah? There's no slow ramping up your traffic or anyway. Yeah? And so really building your systems in such a way that you need to be able to support this. You know, there's you never get a second chance for a first impression. This goes for new services as well. They need to be ready on day 1 to be able to take in the maximum scale possible. This was another hard lesson we learned. Accounts and identity are not the same thing. Yeah, so when we started off, we actually overlaid these two. Yeah? Accounts is billing. Yeah? Identity is the security concept that you use to protect your services. These two things are not the same. But definitely in the first years, we used them for both concepts. And for quite some time, we've been working on really tearing these two things apart to make sure that accounts and account management is something very different from identity and access management. And I like to believe that with IAM and all the policy mechanisms that we've implemented around IAM, we're really giving you that. This was our ignorance on day 1. Yeah, on day 1, we thought, well, you know, we have APIs, some good documentation, and forums. Now, that should be enough. Well, it turned out that was not enough at all. You know? And it was more our ignorance, because originally we were really looking at sort of internet scale developers, and we felt that that was the normal way that you would engage with them. And so the console was not something that we developed initially. It was really feedback from customers saying, no, 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 APIs for management is not enough. We need a visual interface. And that meant that we had to retrofit many pieces back into the console that hadn't really been built for that. These days, there is no service that launches anymore without console support. The same goes for professional support. Yeah, it's really something that you guys asked for, saying, no, we really want the phone number to call to help us with particular problems or with advice. Or professional services, where quite a few of the enterprises really want support at the project management level. All of these things were things that we didn't anticipate up front, where we weren't thinking about on day 1 when we launched, but it is really crucial to actually have the human touch be available, even though you do most of the work that you do in a self-service way. By the way, all of these images were, of course, as you know, of Berlin with clouds in them. But given that the last slide is number 14, I'll pick a color one. You guys know who this is? Ja, natuurlijk. Of course. Yeah. So, given his recent passing, I thought it was more than appropriate that lesson number 14 should be with Johan Cruyff, and I could have called it no goalkeepers. But in this case, it's no gatekeepers. This really has to do with the fact that we strongly believe in this at Amazon, that if you build platforms, you should not put gatekeepers on it. Meaning, we are not going to tell you what you can and what you cannot do. And we've seen that if we remove these gatekeepers, if we are not restricting you in the way that we're using your services, you are going to be so innovative. You're going to use our services for possibly everything except for where we intended them for. Yeah? And you've been really good in this. Yeah? There's a reason why we launched 722 new main features and services last year. Mostly because you want to use our services in every possible way that makes you successful. And the only way to do that is if you have no gatekeepers on this. So with that, I want to close off with what I said this morning as well. There has never been a better time to build and innovate on top of AWS. So with that, go build, go have a great party, and I'll see you guys over there with the beer. See you.